All right, I guess I'll get started. Well, first of all, thanks everyone for joining today, taking the time out to join this webinar. I wanted to share the good news that we've released the 1.3 version of Hyperledger FireFly, and we'll walk through a little bit what is FireFly for people that are new to it. What are the new features in 1.3? I have a demo as well of one of the new features, and then talk a little bit about what's coming next, and maybe if some of you would like to, how to contribute and join the Firefly community. First of all, I'm Enrique Lacal. I'm a full stack software engineer at Kaleido. Kaleido open sourced Hyperledger Firefly a few years ago and contribute a lot of the code and is a really strong supporter of Firefly in the enterprise world. So first of all, I think the first slide is all about just a level set if people are new to Firefly. So a few years ago, Kaleido and the community decided that building Web3 applications could be really repetitive. There are a lot of layers in the stack that you need to care about. First of all, you need to have a chain running, right? You need to have your blockchain nodes running. And then from running the blockchain node all the way up to writing your business applications, there's a lot of layers of complexity that you need to deal with. You need to be able to listen to blockchain transactions and events. You need to be able to index those events into some sort of data store that then you can look up afterwards. You need to be able to submit transactions reliably. You need to be able to sign those transactions with different key material reliably as well. And just a lot of the time spent developing a Web3 application was just what we call the plumbing, was listening to events, getting reliable delivery of those events from on-chain, maybe doing some off-chain and on-chain coordination, where sometimes you might want to do some privacy aspects in there. And really the 20% of each of these applications was actually the business logic. That would be a combination of your smart contract with some off-chain Web3 app, listening to those events and firing other businesses or other internal processes. So Firefly came to be as a tool that will fit in that space and was contributed to the Hyperledger Foundation. So overall, Firefly is what we call the gateway into your Web3, into different chains. It has a support for different types of chains, and we'll talk about that in a bit. And it also allows you to submit transactions to chains, listen to events, manage your identities, store data, store transaction data. So then you can query very efficiently. You can feed those events and those transactions back to your business application. And it kind of, one of the very special things about Firefly is bridging Web3 technologies into Web2. So what you can do with it, one of the examples I'll show as part of the demo, is you can convert any smart contract into an open API, or what was called before a Swagger API, a Web2 API that then your business applications or your existing developers can use to connect and invoke with the chain. So out of the box, just a brief, maybe 10, 30-second overview, has a lot of features. I won't walk through all of these, but I just wanted to give you a little bit of an overview of what it can support. So it's a very enterprise-friendly open source tool. It's built for production. It supports different protocols. It's very pluggable, has different pluggable wallet and key management solutions, different pluggable off-chain messaging support for different event bus technology, very pluggable transaction management layer that we'll talk about to be able to support new ecosystems and new types of chains, and also very pluggable the database layer where you can plug in different databases, and we have different options for that. One of the things I do wanted to highlight before we talk about what's coming to 1.3 is this concept that we have a Firefly blockchain connector framework. Because Firefly is very pluggable, we introduced in one of the earlier releases an interface to a pluggable framework that's written in Golang to help developers write different connectors to their different chains. So today we have, for example, an EVM connector or a Fabric connector, or in this case, we'll look at it in 1.3, a Tezos connectors that can be built using this framework. So this framework allows you to do the heavy lifting again of listening to events, of managing nonces, of monitoring transactions, of getting receipts, of checking checkpoints and storing this in a very reliable way. So then you can feed that through your application. And 80% of the code, I would say, is chain agnostic and can be extended with and contributed by different members of the community to be able to deal with different chains that are not maybe EVM based or different types of networks. So we've done a very job of heavy lifting the very core plumbing and framework to allow people to invest in Firefly and extend it in their own way. And this is going to be very important because I'll talk about one of the things that came as part of 1.3, how we've made this better, and we ongoing features that might go into 1.3.1 that will improve this experience for developers. Another concept of Firefly that is quite unique to it is it doesn't only allow you to be the gateway into your blockchain. As we talked before, it allows you to build your business application without worrying about all the plumbing of eventing, of subscribing to transactions, signing transactions, etc. It also has a complete stack for consortium B2B networks. So the idea, it has an off-chain and on-chain mechanism where you can do data transfers between different organizations, and you have identities for different organizations, and you can send private messaging or broadcast messaging between those organizations. And all that messaging that occurs in that consortium network is automatically hash pinned on chain. So you can use the blockchain as a source of truth of the ordering of what happened, when, and where. And the reason I'm mentioning this is because another feature came into 1.3 that allows you to extend this for your use cases in a more pluggable way. Okay, so that was a little bit an overview of what Firefly can do. There's a different modes, the gateway mode in order to be able to use all the plumbing layer for Web3, and then what we call the multi-party mode, which is the consortium mode, to be able to send events to different organizations and different members, and at the same time use the blockchain as a source of truth. So what's new? What came in this new 1.3 release? It's been about a year since the 1.2 release, so a lot has gone in. So I'm highlighted the big things here, and then I'll talk a bit more through another list of features. One of the things that we did that was a heavy lifting was this modular runtime. So each of the Firefly instances has their own transaction manager that we talked about, and each of those transaction managers can talk to a different flavor of chains, right? EVM, Tezos in this case, or Fabric. We also introduced a few years ago a concept of namespaces. So you could have different namespaces in your Firefly instances, each coupled with a different transaction manager talking to a different chain. So you could have Firefly instance with multiple namespaces, all talking to multiple chains at the same time, so that in your application you can listen to events from multiple chains. We did a heavy lifting of decoupling the internal plumbing of orchestrating those messages across different chains when we're using transaction managers to become more isolated for each namespace. And this was a key requirement to enabling Firefly in the future to be highly available. So you could have multiple instances of those Fireflies and namespaces across those Firefly instances and have more isolation of listening to events and orchestrating and subscribing to different things that are going on in the chain. That was a really big heavy lifting. We'll talk about that in a second. One of the things I'm really proud of is the Tezos connector. So we had 2 members of the Tezos community that have become Firefly maintainers that have used the existing Firefly Transaction Manager toolkit to build a connector into the Tezos ecosystem. The other feature that was quite substantial was what we call Invoke with data. So we talked about that Firefly can solve consortium, can help you build consortium for B2B networks. And as part of that, it has a contract that we call the batch pin contract, where you can send data off chain, and then you can hash that data and pin it on the blockchain for that proof, that record. We've extended that functionality, so now you can use your own contracts with Firefly, and you can pin data with your own contracts. So there's a specific interface that you need to implement and a set of events that you need to emit from your smart contract, and I'll show a demo of that actually today. So we've extended to make it more modular and pluggable, so folks can use their own smart contracts. We made some really significant changes to our connected toolkit for performance. We rewrote a lot of the database layer. We allowed it now support PostgreSQL as a more performant choice over previous database technologies that we had. And we also wrote a lot of how the receipts and how event streams work between Firefly and the transaction manager, how you can listen to events more performantly. We did significant investment into a set of Helm charts that we have. There's a Firefly Helm chart repo to be able to deploy a Firefly stack along with a Besu node and the other components in an easier way. Today we have a Firefly CLI that is a Docker Compose CLI that will run a Firefly stack as a sample locally in your machine. But we've also extended now and updated the Firefly Helm charts with a better experience, so the community has some samples to run on Kubernetes. Finally, but not significantly, we have a really tight integration with the Hyperledger Besu community. Actually, Matt on the call is both a maintainer of Besu and of Firefly, and we've done a lot of performance and integration and probably diagnosis with that community. And we spoke about some of those changes in the previous community call to make that integration more performant. I'll just get a sip of water and then we'll move into the first topic. All right. So, by the numbers. All right. So how has this changed? And you can look at the insights from the Linux Foundation. We've had 64 new contributors into the various repos. So Firefly, the whole community is spread across, I would say, 8 to 10 different repos in GitHub. We've had 6 new maintainers from different companies come on board, over 2,000 new commits across the repos, and 312 stars. So yeah, feel free to come along and start the project. Follow the different GitHub repositories so you can find out what's coming next and keep an eye on it. Okay, so the first one that I briefly touched upon on the overview was around the namespace isolation. So if you can see on the right-hand side, you have your Firefly core instance, which is your core Firefly runtime. And at the bottom, you have your blockchain node. Then we have the Firefly transaction manager, which is that toolkit. In this case, it could be, for example, an EVM transaction manager to communicate with an EVM node. And in Firefly, we have different concept of different namespaces. Before, what we had was a single event stream for all the namespaces in a Firefly instance with the Firefly transaction manager. So there wasn't true isolation of streaming of events between namespaces. So in 1.3, what we've done is we've rewritten that interface. So the interface stays the same, but we've rewritten the way event streams are managed in Firefly. So now each namespace gets their own event stream with the Firefly Transaction Manager. This allows you to have high availability. And this is all done without breaking changes. We've written code inside Firefly that will migrate over those existing namespaces and components to recreate an event stream for each namespace. And it will even handle duplicates. So if you are upgrading from a previous version, your application should not receive duplicate events because we'll handle all that deduplication inside the Firefly runtime. The naming has changed a little bit. Now it's plugin, topic, and namespace. But yeah, significant architectures changes that will hopefully bring a lot more performance and high availability to the Firefly ecosystem. Invoke with data. So we'll have a demo of this in a second. But the main idea behind this is you can couple any off-chain data, any private messaging through Firefly with any smart contract invocation. The way this works is, and I'll show you in a second, you implement your smart contract in a way where you add an extra field for your methods or your chain code, for example, a Fabric one. And that allows us to pin some data on chain and then off-chain send some data to the different options of event bus transport that we have. So it allows to both perform aggregation and emit events with both pieces have been received. So one of the key things of Firefly is it will consume and aggregate and correlate both the on-chain and off-chain data in the order of the chain. So when you're sending loads of events, each of them are getting pinned on chain. All the Firefly runtimes, if you're in a consortium network, will all read the messages in the order of the chain. So using that functionality, but extending it with your own smart contracts that you can now extend. And I'll show a demo of this in a second. The persistent enhancements I talked about. So we've spoken about the Firefly Transaction Manager toolkit and how different Connect implementations have leveraged that, such as the EVM Connect layer. Well, in this new release, we've added support for PostgreSQL as a database choice. Before we were using LevelDB. And we use this database to persist transactions and checkpoints and also to persist subscriptions and listeners. So every time um, Firefly consumes an event, we checkpoint which event it has acknowledged, which event it has received. And we also persist transactions when we're submitting transactions to the chain. So we might receive loads of transactions, and those transactions might not be able to get to the mempool in the nodes. So we might persist them there before we submit them. And you can still query them afterwards if you're using the PostgreSQL database layer. So now you get better transaction history. So you understand where your transaction is, at which level it is. So it might be assigned anons, it might have been signed, it might have been submitted, we might be waiting for confirmation of receipt from that transaction. So with this support, we've also added more metrics into the transaction manager layer and a better API for history tracking of transactions. And there's a specific PR that outlines a lot of the changes that we might just layer, and it really makes it more enterprise ready. This toolkit, and as is implemented in this toolkit, any other connector that gets built in the future will be able to leverage this out of the box. Along with the Firefly Transaction Manager, we have a repo in Firefly called Firefly Common, which is the base of a lot of the Golang repositories for Firefly. And a lot of these enhancements to the database layer will actually contribute to that common repository to be able to talk to PostgreSQL using Golang and all types of foreign key relationship and performance inserts and reads from an SQL database. Tezos connector. So yeah, really happy about this one. New Tezos connector does really show how powerful our blockchain toolkit is and framework. And we've done a webinar with the Tezos community a few months ago around Firefly and around the Tezos connector. And one of the special things about this connector, it has a pluggable point for remote transaction signing. So it's capable of integrating with various key management solutions like HashiCorp Vaults, etc., to allow you to manage your keys more efficiently and sign your transactions into Tezos. And we've had 2 new maintainers that have been added as part of this, and they attend our regular monthly community calls and really talk about features that they need for the Tezos connector and how we can make things better. So a lot there. Those were the 4 main ones I wanted to touch on, but substantial more contributions have gone into 1.3. We've enhanced the subscription model in Firefly. So subscriptions are a way where you can tell Firefly you can teach Firefly to tell it, hey, I want to subscribe to these events, for example, from this contract or from this address. And what we've enhanced today, and as part of this release, is we've added a batching functionality. So now instead of getting one event at a time through WebSocket or through webhooks, you can now get a batch of events. Your applications can process those batches at once, acknowledge that batch, and move on to the next one. So it becomes more efficient. Along the lines of that, we've enhanced the API for querying events. We've seen a lot of users, they've wanted to be able to query for specific events and filter over all the events in the Firefly instance. We've enhanced that. There's another concept in Firefly where we have a set of token connectors that are specific components that are tailored to the EVM ecosystem to handle, for example, ERC20 or ERC721 smart contracts, or we have another one for ERC1155. These token connectors work alongside Firefly, and we have this concept of token pools. So we can manage if a new token has been minted, the new token has been burned, etc. Then we can, in Firefly has a UI and those token indexers to be able to read all that data and correlate it and show it to the user. What we've done as well as part of 1.3 is we've changed the way those token pools are created in a consortium network. So in a consortium network, when you create a new token pool, and alongside it, you create a contract interface to show that where this contract has been deployed and what is the ABI interface, for example, in the EVM. We've changed that between publishing that token pool to all the network into 2 steps. Now you can define your token pool, you can test privately You can mint tokens, burn tokens before you want to share the existence of that token pool with the rest of the network by having a separate API call with publish. We've done more database operations. A lot has gone into inserts of events into the database. So now we batch a lot of the transactions into groups for SQL. So that's a lot of performance changes. We now allowed cancellation of batch stuck in this batch. So a batch is, for those who are not aware, when we do the multi-party consortium setup, or even none, we batch events. All the events get batched into what we call a batch, and then that gets pinned on chain. Sometimes if that batch is waiting on some off-chain event or something is stuck, now you can cancel it and carry on if you're not interested in processing that batch, for example. We've upgraded to a new Golang version, more CVE fixes, and yeah, a lot of best improvements around performance and problem diagnosis, especially around receipt and revert reasons. We've talked about specific methods that Besu has around receipt handling, different JSON RPC methods I'm talking about that we might want to introduce into FireFly as an optional thing to better integrate those two ecosystems. Along with every new release of any software, there are migration concerns, and we've written a guide talking a lot about the different changes, but I wanted to highlight two. We've changed the way the Docker image file permission changes. So there are now specific users in the Docker file. So if you are going to install FireFly in different environments, such as Kubernetes or locally in Docker, be aware of that, that we're no longer using the root user, for example, in the Docker files. And what I spoke before around the contract interfaces and the token pools now have distinct steps in creating the token pool and then publishing them in the case of a consortium network. All right. I'm going to move on to a demo, but I'll give it maybe a few minutes if people have questions. I see a lot on the chat. So I don't know, Matt, is there anything that I should take a look at here?
Yeah. No, nothing leaps out at the moment. Enrique. A question from Jim just around Fabric v3 support. That's not something I'm super familiar with. I don't know if you are.
Okay, so we do have a Fabric connector, but I think the V3 support is limited at the moment. I did have a look into that. But yeah, maybe we can take that one on Discord. That'll be awesome to understand what has gone into Fabric v3 and what are the things that have changed that might affect our connector.
Great. Thanks, Enrique. Yeah, I think you're good to carry on.
Cool. All right, so let's talk. Let's go. Let's go through the demo. So I'll stop here. Okay, so as I mentioned before, we have FireFly CLI. So this is a command line interface that allows you to really rapidly start up a FireFly stack with all its components locally in Docker. So I have one running right here. So these are the components. I have a FireFly running. I have the token connectors running. I have an EVM connect, transaction manager running. We also have this concept of a sandbox that you can take a look. It's a little UI where you can play around and create tokens and send messages. You can get a feel of what FireFly can do. We use IPFS for the messaging layer, the consortium layer, so we can do broadcasts of different messages to IPFS. And I also have a get node just running at the moment. Oh, alongside I also have a data exchange, which is the component to do private peer-to-peer messaging. In this case, it's the HTTPS component, so I can talk peer-to-peer between two members. So here, as you can see, there are two containers for each because there are two members in the network, and I've set up this in the multi-part network. We've written a guide on how to pin data using your own smart contracts. So we've talked about this. What I want to demo is the idea that you can now pin off-chain data to a custom blockchain transaction to any smart contract that you wish to develop. And the contract looks a little bit like this, the one that we have as a sample. So we'll just briefly talk through it, and then we'll show you the demo. So this is obviously opinionated in terms of Ethereum, but you can do the same thing for Fabric in this case. But what this requires is for you to extend your contract with an extra field called data and to call a function from the multi-party contract. So by default, Firefly, when you set up in a multi-party contract, a multi-party mode, will deploy a multi-party contract that we call the batch pin contract. And it will use that for pinning those messages, either those private or those public messages on chain. So in order to extend your own smart contracts to have the same functionality of pinning, you need to build on top of that existing contract. And in this case, in the Solidity language, you can just call that instance of the contract with the data that you want to pin. And that's why you need to set the address of the multi-party contract. So what I've done is, and we can walk through this. So I've opened up my Firefly. So this is the Firefly dashboard that gives you all the information about the different transactions and messages and operations that your Firefly node is doing. We also have a Swagger UI for all the APIs from Firefly. And what I've done first is, and we can walk through it, is I'm going to deploy that sample contract. So I have I've constructed the request body just to help us with time. So I've compiled that contract down into bytecode. I've given it the definition of the contract. So the ABI, right? So we have a say hello function that takes in that data payload. We have a hello event that gets emitted. And we also have a function to set that multi-party Firefly address. So if I go and execute that, and we don't have any inputs because the constructor of our smart contract doesn't require any inputs. If I execute that, I get back a succeeded. And if I go all the way down, I can see that now we have a contract location. So that's where we've deployed our new smart contract onto our get node. So now what I can go ahead and do is create what we call a contract interface. So we spoke about that Firefly is a gateway from Web 2 to Web 3. And one of the things that it can do is I can create open API definition for your smart contract based, for example, on the ABI or any other format. We have a format called the Firefly interface that is non-blockchain opinionated, so blockchain agnostic, to create those open APIs. So we have a handy API called generate, where you can give it the ABI of such contract. So we give it such ABI of such contract, and we run execute, and it'll give us back the generated non-blockchain opinionated interface format that Firefly needs. We can go ahead and copy that, and then we can go and create an interface for our contract. So we have a post method in here that I ran earlier. And if we just go ahead and clear all of this, you will see that now we can give it a name. So we'll do custom pin demo. We can give it a version. So these interfaces are version. These are the methods from our contract. So we talked about the say hello method, the set Firefly address, and the events that get emitted. And we also have this publish true, right? We talked about the decoupling, that it won't get published. So I do want to publish. I want to tell everybody in my network about this new contract and, I misspelled custom, about this new contract that I'm using to send messages. And yeah, we'll set publish to true here as well. So if I execute that, if everything goes well, we'll give it a second. I'll scroll down. And now what we've done, we've created an interface. So we've defined an interface in the version of that contract. So from an interface, now what we can create is an API. So for an API, what you need, and we'll go up here, is you need the interface. So it knows what is the schema, right, of your contract. You need the name. So we'll do demo custom pin, for example, and it also needs the address of where your contract is deployed. And again, this is blockchain agnostic. So in this case, it's an EVM address, but it could also be a chain code, right? A channel, etc. For Fabric. So if we scroll down all the way to where I deploy that contract, we should get the address of contract location. And if I scroll all the way up, we can put that there. So now we're going to create a new API for that contract. So we've created that, and now we get a URL for a UI, for example. So if I go over here, I already have it open. In this case, we've called it demo custom pin. So what I can do is just I'll rename this one so we have less tabs. Demo custom pin. And now we have a Swagger interface, Open API interface into a contract. So the first thing we need to do is we need to set the address for our multi-party contract. So our contract can use that to pin data. So what I'll need to go is I'll need to go and find that address. So normally what I look at is previous operations that I've done in that multi-party contract. For example, in this case, blockchain invoke. I did this earlier in terms of, for example, look at blockchain batch bin. For example, this one should have an address. Contract. Let's have a look if I can find it. If not, it will always be set on the configuration of your FireFly instance. So if I go to can't seem to see it right now, but I can do the following. If I go back to our dashboard, transactions, batch bin, this transaction should have an address, and it's that one right there. So that address is the one I want, which is the default. You can see it's called the listener name. That's a way, a construct in FireFly to be able to listen to events. It's the default batch bin contract. So if we go back to our Swagger UI for this the custom contract, right? This sample hello contract I've used and that we've documented. I now provide the multi-party contract address. I'm going to use the default key that comes with FireFly. I wouldn't recommend it, but it's convenient to get started. But there's a default key when you set up a multi-party mode for the identity of that organization. So if you don't provide a key, it will use that one. I recommend you use your own key to sign these transactions. The other thing that we also have in the API is an idempotency key, which is a feature that is very common now in a lot of HTTP APIs. So you provide a unique key so that you can submit, you can retry as many times as you wish, and it will only do it once, for example. So in this case, we can just give it a my demo. So we don't set the FireFly address twice. So now if we execute that, and what you get from these Invoke APIs, you get the transaction won't automatically be confirmed if you don't set a parameter to true. What will happen is you'll get an async reply. You say, okay, cool. I've received your request to invoke the contract. It's currently pending, and it will wait for a receipt from the chain to go through before it gets confirmed. So if we go back to the Swagger Explorer and we look at transactions and we refresh that, you can see that we've invoked the contract. And now if we look into more detail, you will see the output and the detail of the contract. And here is a little bit of what we spoke about earlier about how we've extended that history summary in the transaction toolkit, right? In the transaction manager toolkit, where you can see the different steps my transaction went through. I've received the transaction, I've assigned the nonce, I retrieved the gas price, I submit a transaction, I received the receipt, I can confirm that transaction did go through. So now we can see that we've succeeded, and that transaction correctly went through, and that we called the set FireFly API and etc. With that address at the input. So then the next thing we have to do now is we can then call the say hello function with any data, in this case, that we want to pin on chain. So the way this works is there is an as documented here, we've introduced an extra message field into all the Invoke payloads for smart contracts, all the APIs. So if we try that out, I'll just do that, and we can do this is my demo payload, for example, and it doesn't need any input because automatically it will map that data field in the message will map to the data field inside the smart contract that we defined up here, this one here. So let's go ahead and everything goes well. We should see a few things happening. So we execute that. Our blockchain invoke as initialized. We can go back to our Explorer. We can hit refresh. Oh, I've just filtered over things. We can see that we now have a new transaction, which is called contract invoke with pin. And what you can see now is that we've called that method, but what's actually happened is two things. One is a blockchain invoke operation. So we've invoked the blockchain. And the other one is that we've uploaded that message to the shared storage. So because it was a public message, it will be uploaded to IPFS and broadcasted. So if we look at messages, we will see a broadcast a few seconds ago, which is the one that we want to send. And if you look at the contents of it, this is my demo payload. So I've just proved that you can use the existing features in FireFly to orchestrate on-chain and off-chain coordination. So on-chain hash pinning and off-chain peer-to-peer messaging, or broadcasting in this case to IPFS, using your own contract. So you can extend it in a few lines of code, and you can use already the features that FireFly has for private messaging. That's super useful for a lot of use cases. All right, any questions on the demo? And now I'll go back and talk a little bit more about what's coming next in FireFly.
Nothing on the chat at the moment, Enrique.
Awesome. Thanks, Matt. Okay, so we come back in here. All right, so what's coming next? There's been a lot of features in 1.3. It's been over, just a year since the 1.2 release, so a lot there. And there's a lot more that I haven't mentioned around fixes and loads of other things. But we want to keep the train going, and we want to plan out maybe a 1.31 in the short term that will allow us to put a few more features that will give a really good experience to FireFly. One of them that I think is quite significant is confirmation listeners. So today you have the ability to listen to events that have happened, the ability to see that your transactions have succeeded through receipts. But now we want to be able to stream all those receipts through the blockchain connected toolkit all the way up to FireFly, even if you wish for your applications, with better filtering and acknowledgements. So you can use those receipts in your own applications more easily. And we've spoken about in the past that maybe some Besu JSON RPC methods are more suited to be able to get all the receipts for example, for a block, so you can more performantly get the receipts for all transactions. Another thing that we've done recently is we've enhanced the performance toolkit. So we have a performance CLI that we use quite heavily. We've enhanced this to now support ERC20 transfers, and that's driving new optimizations into our blockchain connector toolkit, specifically our EVM connector. We've added new event metrics to our blockchain toolkit framework, so you can integrate the metrics that are reported from the blockchain toolkit framework into Prometheus very easily. We already had existing metrics, but we have more metrics now around events and the amount of events that get outputted. We realized that the multi-party experience of registering an identity in a consortium and that API was a bit lacking in terms of user experience and visibility. So we've given more visibility at the point of registration. So when you register your FireFly node in a multi-party setup, you get more information of where the registering process is. So I'd recommend you read deeper into if you do care about multi-party setups, how identities work in FireFly. We have this concept of an org identity and a node identity. One of it is the org is the on-chain identity of a specific FireFly node, and the node is the off-chain identity. So there's a registration process of registering both the org and the node There's a process of registering the org and the node, and before the FireFly node can be registered into the network. So a lot of node words in there. Finally, there's a PR ongoing at the moment that we want to get for 1.31, which is today you can define, as we define those contract interfaces and those APIs, another API available where you can define contract listeners. So if your application wants to listen to a specific contract and a specific event in a contract, you can define one of those, and then through a subscription, you can listen to all those events. We're extending it to allow multiple filters. So you can listen to multiple type of events with one contract listener and even across different locations. So for example, if you have, let's say 20 ERC20 smart contracts and you want to listen to all the events from those smart contracts, you can define one listener and you get all of those for free. Finally, ongoing collaboration. I've mentioned it a few times with Hyperledger Best on performance. There's loads of updates there, and I look forward to more collaboration there. And many more enhancements around CVE fixes and a lot of things going into Firefly Common to make the experience better. Finally, this is a call to join the Firefly community. I'm active most days on Discord, answering people's questions and suggestions using Firefly. So I welcome people to join. There are different channels. We have a Firefly newbie channel, a Firefly workshop. We also have an announcement channel. So yeah, feel free to come in there, ask me any questions, and the maintainers will join in, and I'll pull in the respective experts in different areas to try and help. And also join the activity on GitHub. We have loads of repos. There are good first issues to contribute. And don't be afraid to ask any questions in the issues or pick up anything that you wish to try out. And yeah, I welcome any contributions. And just a call for Kaleido. So as I mentioned at the beginning, I'm a full stack software engineer at Kaleido. Kaleido is a company that provides blockchain digital assets and tokenization solutions for enterprise organization. We've been working with the Hyperledger Foundation for a number of years now, and we host loads of webinars with the Hyperledger Foundation. And we just make it really simple to run blockchain and to tokenize assets. So you can sign up for free at www.kaleido.io. You can get a Firefly node running. You can get a blockchain node. We support loads of different chains. And you can get started building your own Web3 solutions. And I think that's it. Thank you so much for listening. I hope that was useful. You got a little bit of a view of what Firefly is if you're new to the ecosystem. And hopefully that makes you eager to try it out in your applications and really streamline the way you develop Web3 applications. And for those that know about Firefly, hopefully you see the ongoing pipeline of new features that have gone into 1.3 and the next features that will go into the next releases and the active community and GitHub presence that Firefly really has. We also have a lot of blogs on how Firefly is used in different use cases, and I really encourage everyone to look at those. So yeah, thanks everyone. Any questions, I'll stay in. We still have 15 minutes for Q&A.
Thanks, Enrique. No, there was just a question about kind of tutorials for any of the latest features. So I posted a link to the latest docs because I know all the new features will be documented, not necessarily with kind of step-by-step tutorials, but if there are any other guides that we've written, maybe it would be good to post those in the Discord channel for anyone who wants to go and follow up them and have a look at any of those.
Sure, yeah. So we have that guide on the pinning data. There is a README on Tezos, and I think we have also a document on connecting to Tezos. And then we also have some documentation around the database support in the transaction manager, but that's mostly in code, I would say. I see another question here from AA. Is there a contact name for email we can reach for any needed support? So it depends what type of support we're talking about. So I guess, yeah, I'm available in Discord most of the time if you want to reach out to me there. Okay, I'll give it a few more minutes if everyone has any questions. And then yeah. And just final note, we have a community call that runs every month. So feel free to come along to those. We discuss new features and new proposals, and if you have any new ideas into the project. And we also have a Firefly improvements proposals where we frequently write improvement proposals. Rodrigo Pintus, you mentioned multi-party contract, right? Could you explain what is that? Maybe I can read on the documentation. Okay, really good question. So the multi-party contract is a contract that gets installed by Firefly to support messaging. So it's very similar to the previous contract we talked about. It's a hash pinning contract. So that multi-party contract allows us to pin data onto the contract and then correlate the on-chain data with the off-chain data that gets sent across. So if we look briefly at the FireFly documentation, so you can find the contract in the FireFly contract section. So if you go to the GitHub repo and you go to smart contracts, you can the different versions are here. It's the default. This is the FireFly contract. So it has a set of methods to be able to pin data on chain. So for example, in this case, it's pinning a batch pin record, etc. Or even you can also pin here identities that get registered as part of the consortium. And there is a documentation around this in FireFly. I'd recommend understanding FireFly and maybe the multi-party features. This is a really good source for that. But yeah, feel free to reach out on Discord for any questions on that area. Okay. Well, I guess I'll give some time back. And thanks everyone for joining today.
Maybe a quick question, Enric.
Go for
You
it.
said that you guys have a community call once a month. How to join that call?
That is a great question. Thanks, Undiata. So if I'm not showing my screen, but I'll share a link to that there. So it's through the Hyperledger calendar. Let me just get that up 1 second, and I'll share this here. So this is the public calendar. Oh, 1 second. Here you go. That is the public meetings for all Hyperledger. And the one you want to look for is specifically FireFly. So if we look at let me see if I can just find the FireFly one 1 second, and I'll give that to you. Here you go. I've sent you, for example, the latest one that we've run. There's a regular, it shows you there the Zoom link and the regular invites that you can sign up to.
Thanks a lot.
No problem. All right, I guess I'll end the call there. Thanks, everyone. Have a great day.
Thank you.